All right, so hopefully you got a good feel for how these inverses work now and that you can evaluate the inverse and find an angle for a certain ratio. Now, as you can see here on this screen, we're going to start applying inverses to the original trig functions. And we're going to see some interesting things that are going to happen here, some good thinking, and I'm excited for our video today. So first up, we've got the inverse sine of the sine of pi over 3. Now, we might think right away, inverses. What do inverses do, okay, to the original function? We say they cancel each other out, right? Okay, we say, okay, this is going to cancel out, and this is going to be pi over 3. To use a non-trig example, if I square something and then take the square root, squaring and square roots are inverses, we get back to the original, which is 3. They cancel each other out. Okay. But I want to actually walk you through the full process here to see what happens. Let's move this out of the way. Okay. Maybe we'll just erase it. Okay. So here's how we can think about it. I like this notation better here. So the arc sine of the sine of pi over 3. Well, we got to follow order of operations, work inside out here. So this is the arc sine of, what's the sine of pi over 3? So I go to my unit circle, I find pi over 3, the sine of pi over 3 is root 3 over 2. Now, what is the arc sine of root 3 over 2? So I go back to my unit circle. I recall that arc sine is restricted to the right half of the unit circle, which goes from negative pi over 2 to pi over 2. And what angle has a sine of root 3 over 2? That's just pi over 3. Okay, so we do see that they cancel, and it does give us pi over 3. But let's see what happens in the next one. Okay, so just like the last one, we say, okay, inverse, they're going to cancel. This is going to give me 2 pi over 3. But let's write this out and take the arc sine of the sine of 2 pi over 3. Well, this is the arc sine of, what's the sine of 2 pi over 3? So here we go, unit circle, 2 pi over 3. The sine is root 3 over 2. Aha. So now I take the arc sine of root 3 over 2. Don't make the mistake of saying, oh, well, who's the angle whose sine is root 3 over 2? It's 2 pi over 3, because you can't go over there. Remember, we are restricted to the right half of the unit circle. So where do we actually have to look? Okay, we have to find root 3 over 2 on the right half of our unit circle for sine. And that happens right here, correct? Which is at pi over 3. So here we see an example where they do not cancel. It doesn't always work that way. Let's go back to that example that I tried to show you, where I said, okay, if you take the square root of something squared, you get back to what you started with. But is that really always true? If you always take the square root of something squared, you always get the original. What would have happened if I would have taken and squared negative 3 and then taken the square root? This is equal to the square root of, what's negative 3 squared? 9, and the square root of 9 is 3. Did I get back to my original? No, they don't cancel each other out. You have to be very careful about domains and ranges when working with inverses. So let this be a warning to you. You cannot just assume that they're going to cancel out. Sometimes is that going to happen? Yes. When is that going to happen? When this angle is where it belongs on our part of our circle. So for arc sine, this angle has to be an angle from negative pi over 2 to pi over 2. This one was not from negative pi over 2 to pi over 2. So we didn't end up back where we started with. All right, let's go to the next one. The arc cosine of the cosine of 2 pi over 3. Well, what is the cosine of 2 pi over 3? 2 pi over 3, that's negative 1/2. So now we have to find the arc cosine of negative 1/2. So where are we restricted to for arc cosine? Top half of the unit circle. So where on the top half of the unit circle is the cosine equal to negative 1/2? Right there, which is at 2 pi over 3. So we do get back to that original angle again. And why? Well, just like here, I said that this angle, if we're taking the arc sine of the sine, the angle has to be from negative pi over 2 to pi over 2 because that's the range of the, range of arc sine. Okay, this is within the range of arc cosine, which is from 0 to pi. That's in it. So we got back to where we started with. Now, if we look at this one, is negative pi over 3 in the range of arc cosine of 0 to pi? No, it's not. So we're going to expect on this one, we're going to get a different answer. So we're going to take the arc cosine of the cosine of negative pi over 3. That is the arc cosine. What is the cosine of negative pi over 3? Negative pi over 3 would be what, right down here? That's pi over 3 backwards. That is 1/2. So now we say, okay, what's the arc cosine of 1/2? Now remember, we're restricted, and we say where on the top half of the circle is the cosine equal to 1/2? It's right here, which is at pi over 3. There we go. So you be very careful with your domain and ranges. Okay. These were able to cancel out. Those were able to cancel out. These were not. Let's try another one. The arc cosine of the sine of 11 pi over 4. Now, what's different about this one than the last one? Okay, or any of them on the last page? Well, here it was always inverse sine, sine, inverse sine, sine, inverse cosine, cosine, inverse cosine, cosine. It was the inverse of its inverse, right? It was cosine with cosine. Well, here now we have a cosine with a sine. So we're going to take the arc cosine, start on the inside. What's the sine of negative 11 pi over 4? Let's see here, negative 11 pi over 4. Negative 11 pi over 4. Well, let's see here. Negative 8 pi over 4 is negative 2 pi. That's one revolution. We have to go an additional negative 3 pi over 4 past one revolution. So here I am, I'm going negative. That's negative 8 pi over 4. Now we have to go another negative 3 pi over 4. Well, there's negative 1 pi over 4, negative 2 pi over 4, negative 3 pi over 4, right here. And we wanted to find what? The sine of negative 11 pi over 4, which is negative root 2 over 2. Now we're going to find the arc cosine of negative root 2 over 2. So we go back to our unit circle. Arc cosine is the top half of the unit circle. So where on the top half of the unit circle is cosine equal to negative root 2 over 2? Right here, which is 3 pi over 4. There we go. All right, so now what we're going to do is actually we're going to see what happens when we step away from our unit circle. Okay. Also notice that this time the inverse is on the inside. And that's what we're going to look at for the next two, is what happens when the inverse is on the inside. So we're going to take the sine of the arc cosine of 4/5. Now, 4/5 is not on our unit circle. Remember that arc cosine is the angle whose cosine is 4/5. Okay, now when we say the angle whose cosine is 4/5, let's call that angle theta. So in other words, it tells us the cosine of theta has to equal 4/5. So to handle that, I'm going to make a sketch. Now, arc cosine, we're restricted to the top half of the unit circle. What would it look like for the cosine to be 4/5? Well, cosine is the x value. Okay, so I'm going to draw this in the first quadrant because we have a positive cosine, not a negative like we would in the second quadrant. I'm going to call this my angle theta, and then the x value is 4/5. Now I want to find the sine of the angle whose cosine is 4/5. So how do we do this? Well, I could do this as 4/5 for 1 and 1, and I can solve for this side, and I have the sine. We've talked about this. I know it was a long time ago. If you don't want to use 4/5 and 1, you could call this 4 and that 5. Because is the cosine of this angle still 4/5? Yep, we can solve for this, and that's what I want to do here. Let's see here. How would I solve for this? I'd use the Pythagorean theorem. As we have a right triangle, this is 25, that's 16. Hopefully you recognize this and don't have to actually use the Pythagorean theorem, and just know that that's the triple 3, 4, 5. So we're taking the sine of the angle whose cosine is 4/5, which means we're taking the sine of that angle, which we're calling theta. And what is the sine of theta in this problem? Opposite over hypotenuse, 3/5. Let's look at one more. The cosine of the inverse tangent of 5/12. Okay. Now, the inside again is the angle whose tangent is 5/12. In other words, if we call that angle theta, the tangent of theta equals 5/12. Let's draw that up. Arctangent is restricted to the right half. This is positive. We're going to be in the first quadrant again. Let's say like this maybe. I'm going to call this angle theta. I want the tangent of theta to be 5/12. I'm going to choose this to be 5. I'm going to choose that to be 12. So we want the cosine of this angle. So we want the cosine of theta. To find cosine, we need to know hypotenuse. Again, you could use the Pythagorean theorem. Hopefully you guys recognize this is a 5/12. Very good. 13. Pythagorean triple. And the cosine of theta is 12/13 adjacent over hypotenuse. So if you have the inverse on the inside, okay, you can possibly use the unit circle if you have a ratio here that's already on it, like maybe a 1 or a √3, something like that. Or if you're not on the unit circle, draw out your triangle. Okay. Think about the arc tangent, arc sine, arc cosine is the angle whose arc sine, tangent, cosine is whatever. Use that to draw your triangle, and then find the trig function at that angle. So go ahead and work with this. I hope it's helpful. We'll see you next time.